Assalamu alaikum. My name is Usama Shafiq and my topic is nuclear chemistry. So, without wasting time, let's straight into it. The question is, what is nuclear chemistry? Definition: the branch of chemistry which deals with the nuclear reactions, radioisotopes, and their use in chemistry is called nuclear chemistry. Introduction. Fermi introduced in 1942 about nuclear chemistry. Large amount of energy stored in nuclei of atoms. The nature of radioactive emission. First of all, cathode ray oscilloscope CRO, then alpha rays, beta rays, and gamma rays. After that, details of atomic structures were not yet known. First, alpha particles. Alpha rays consist of positively charged particles. It has 2 protons and 2 neutrons. Total mass is 4 AMU. It is identical, that is helium is equal to 4 atoms. Properties of alpha particles. Velocity of particle discrete. It varies from under 4 MeV for longest lived emitters. Interaction of alpha particles with gas result in ionization. Beta particles consist of negative charge particles whose mass and charge are identical to electrons. Charge on beta particle is -1. Actual mass of beta particle is 0.00055 AMU. Properties of beta particles. Velocity of beta particle is 0.995. These particles are not emitted with fixed discrete energies. Penetration range of beta particles is 500 times. Gamma rays. They are undeflected by electric or magnetic field, therefore carry no charge. These rays have very short wavelength, electromagnetic radiations. Excited state of atom produce these rays artificially. Now, properties of gamma rays. Gamma rays travel with speed of light. They are weak ionizing gas. Its energy lies between 0.1 to 2 MeV. Methods for detection and measurement of radioactivity. Wilson-Clown chamber method, Gulgen-Muller counter, and Skilshan counter. Nuclear transformation. In 1919, Rutherford bombarded and with alpha particles he produced the isotopes of oxygen. Many of these elements are short-lived, and as a result only high atomic number isotopes have ever been formed. Half-life period. Half-life period is the time required for the disappearance of one half of the original amount of radioactive substance. Average life is equal to 1.44 T1/2A. For example, half-life of radium is 24,000 years approximately. Nuclear fission. The process of splitting a heavy nucleus into two equal halves is called nuclear fission. It is a chain reaction. Atomic bomb is based on the principle of nuclear fission. Nuclear fusion. The process involves the combination of several light nuclei to form a single nucleus of heavy mass. It requires high temperature greater than 1 lakh Kelvin. Hydrogen bomb is based on principle of nuclear fusion. Now, nuclear reactors. Nuclear reactor is a device to produce nuclear energy in a controlled way to be used for peaceful purposes. The essential parts of reactors are core, moderator, control rods, coolant, protective screen. Important applications of radioactivity. Atomic structure revealed, new source energy, sterilization, radiotherapy, radioactive dating, preparation of nuclear batteries. Uses of radioactive isotopes. Exchange phenomena, Second, discovery of new compounds. Third, radiometric titrations. Fourth, application in agriculture. Fifth, application in biology. Biological effects. Origin of phosphatides in egg yolk. To trace the origin of phosphatides in the egg yolk of the hens, sodium phosphate containing radioactive phosphorus was administered to a hen. Photosynthesis of plant. Exposing plants to radioactive carbon dioxide in the presence of sunlight for different intervals of time. Man is 98% born again every year. Scientists establish from trace studies that atomic turnover in our body is complete. 90% of all atoms in our body will be replaced by new atoms. Trace and trace technique. The majority of elements occur as a mixture of isotopes, the proportion of which remains constant throughout the course of physical, chemical, and biological changes. Therapeutic uses. Treatment of thyroid gland, treatment of cancer by radiation, treatment of non-healing wounds, treatment of leukemia. Radioactive decay series, a consequence in which one radioactive nucleus decay to a second, which then decay to a third, and so on, is called radioactive decay series. Conclusion. Nuclear chemistry is the chemistry of radioactive elements such as actinides, radium, and radon. The main point of this research was focused on the benefit and disadvantages of nuclear chemistry and energy. Thank you very much for your cooperation and listening. Allah Hafiz.